And we're going to continue on number 7. So the first thing we want to do is solve for x. So I'm going to add 5 to both sides. So I have 3 less than or equal to 3x. Now I'm going to divide everything by 3 to get x by itself. So 1 is less than or equal to x is less than or equal to 4. Now I want to break this apart. My first one is going to be to graph this x, open mouth to the x, open mouth to the x. X is greater than or equal to 1. Then my next one's going to be is x is less than or equal to 4. Okay, so I'm going to sketch these so we can name our answer in interval notation. So I have a 1 and a 4. X is greater than or equal to 1. So it's a bracket, say this way. X is less than or equal to 4, so it's a bracket on the 4, shaded to the less than side. And our answer is solution, it's going to be and. Where do these two overlap? If I put these graphs right on top of each other, they overlap from 1 to 4 with brackets. So interval notation, as I read left to right, is just going to be bracket 1 to bracket 4. And that's our interval notation. That's our solution. Okay, now we're going to be working with the compound inequality containing an OR. And it says a value is a solution of a compound inequality containing OR if it is a solution of either one. So if either one is represented in the top, it gets represented in the solution as well. So let's go ahead and graph the first inequality on number 8, which is x is less than 4. So we go to 4, we put a parenthesis, and we're less than. Okay, x is less than 5, so we go to 5, we put a parenthesis, and we're less than. Okay, if it's represented in the top, that means if either one of them is graphed in the top, then it gets to be included in the solution. So if I'm reading it, everywhere that's shaded, it's going to be included. So the blue one stops here, but since the red one is covered right there, it also gets to be part of my solution. So if one or more is included, pretty much if you sandwich those on top of each other, we want to represent every part that was ever shaded or touched. So now as I read this from left to right, I have negative infinity to 5. Alright, number 9, we have x is greater than or equal to negative 2. So it's a bracket on negative 2, shade to the right. X is less than or equal to 2, so it's positive 2. Okay, if it was represented above, then it's going to be in the solution. So because the red part was graphed here, it gets to count in my solution. And then the blue picks up, all of this is the red portion, but then the blue picks up from this part on. So it's going to cover the whole entire. If I smash the red and blue together, it covers the whole graph. So our solution in interval notation, as you read left to right, is the leftmost is an arrow pointing to the left, and then it finishes at an arrow pointing to the right, which is a positive infinity. So it covers the whole solution set, which is negative infinity to positive. Alright, number 10, now we're going to solve them. If I divide both sides by a negative, we have a rule that says you have to flip the inequality. Okay, we got to remember our rules. So x is greater than or equal to 2. Over here, I'm just going to solve for x, so I add 20 to both sides. And I have 5x is greater than or equal to 25. divide by 5, and x is greater than or equal to 5. So I want a quick sketch of these two inequalities and then graph the OR solution set. I have a 2 and a 5. So if I do x is greater than or equal to 2 in the top one, that's a bracket on the 2, shade to the right. And on my other one, if I graph x is greater than or equal to 5, okay, and if I was to do, if either one of them is included, I can graph, then I put it in my answer. So if I sandwich those together, I need to represent what I would see. I would see from here to here, my bottom line would be graphed. So I want to describe that. As I read left to right, the first thing I come to is a bracket 2, and it ends at an arrow to the right, which is a positive infinity. Alright, number 11, subtract 4. X is less than negative 4, and then over here I'm going to be dividing by 6, and my other one's going to be x is greater than negative 2. So I want to be able to graph these. I have a negative 4 and a negative 2. Make sure these are in order according to the number line. Okay, my first one is x is less than negative 4. That's here. And x is greater than negative 2 would be a parenthesis shaded here. And it says if either inequality is shaded in the top, it gets shaded in the bottom. So if I was to sandwich that down onto the bottom line, I would have this one from the blue, and I would have this one from the red. So I need to name that as I read left to right. Interval notation. The very first thing I'll come to, arrow to the left, is a negative infinity, and it stops at negative 4 with the parenthesis. Okay, now there is a gap right here. I have to represent this gap. It's going to be a union. It's going to be just like a U, union, and then it picks back up at negative 2 with the parenthesis, and it continues on to an arrow to the right, which is a positive infinity. So interval notation for this OR is going to look like this.